Hello, folks. We are live with this live session about all things Kotlin. I am Anton Arkhipov. I'm a developer advocate in Kotlin team, and today with me I have Alejandro. Hello, Alejandro.
Hi.
He is the engineer on the language evolutions team for Kotlin, and we have seen Alejandro presenting on this channel before when he was a member of Arrow library, one of the maintainers, and he was presenting about functional programming in Kotlin and with Arrow. And now Serrano is actually a member of Kotlin team. So today we're gonna dive into pattern matching. And pattern matching has been a hot topic recently, especially in the Java community, because Java added pattern matching. And well, we had an idea to explore it a little bit with Alejandro and bring some interesting details from the Kotlin language to see how the same stuff could be achieved both in Java and Kotlin and maybe some other languages. And without further discussion, I think we can bring your screen up
Yeah.
and start from there.
Yeah. So yeah, thanks for the introduction. So indeed, I'm here showing some Scala, because actually uh, pattern matching. So we are hearing it, I think, more and more because well, Java is bringing it. For example, but pattern matching is kind of a very old feature. So there are entire languages like Haskell, where essentially pattern matching is the only way you have to treat data. And uh, yeah, so many languages already have it. I want to show first maybe a bit of what you can do as introduction, because maybe people have heard about what pattern matching is, but they don't know exactly what pattern matching is how when you write some code. So I have here an example. I do programming languages, so I have my example where you do a very small programming language where you have like some expressions, and then these expressions could be numbers, Boolean, or a binary operation. So you can think of like uh, having a left side and a right side, and then something in between. So something like uh, something like 3 plus 2. This is essentially a binary thing with a number literal of 3, and then the operation operator plus, and then a number literal of 2. So you use this to represent this, and this I think is a very nice kind of program to show how you treat this data using pattern matching. I have an example here where I'm defining a function to given one of these expressions to evaluate it. Like for example, in the previous case, I have an expression which represents 3 plus 2, and the idea is that you will get a 5 as a result. So in a Scala, the pattern matching is done using this keyword match. And essentially, what you can do in pattern matching is a combination of checking, in the case of a Scala, one of these cases, depending on the language, what exactly you can check there. It's a bit different, but you can imagine for most languages in the JVM, that's going to be something related to the type. And at the same time, you can also extract some information. So for example, the case of a number literal has a number inside of it. So by the way, these case classes in a Scala are essentially like data classes in Kotlin, or if we go farther to Java, similar to records. But well, the point here is that this holds some value, and the binary expression also holds these 3 values. So when doing pattern matching, you can directly extract this at once. So for example, if I have a binary thing, I can extract the left, the operation, and the right. But the main power of pattern matching actually comes not only that you can do this kind of joint checking and destructuring, is that you can actually do this deeper and deeper. So in this case, I'm combining, in this case in which I'm checking the plus, I'm actually combining a check whether something is a binary operation. I'm extracting the left and the right, and then I'm checking whether the operation is a plus, in this case, a times and and. And this can be nested as much as you can. So you can imagine going down and checking the shape of the thing you want to evaluate or the operation and extracting some pieces of data all at once. So this is what pattern matching allows us. The name essentially comes from this thing being called a pattern, and then you try to have so you can think of this as kind of a shape, and then you try to have a value and try to match it through the pattern. And if it actually can click there, you will have extracted some pieces and values there. So this is what you can do. Scala is one of the languages in the JVM which has, let's say, full pattern matching. You can do most of the things that you can do everywhere. So we could, for example, have an extra case in which we say, oh, we do something special for the number 0, just as an example, and then we can here have like again, as I mentioned, a recursive check where we check not only the value but whether the value is equal to 0. So this is like kind of an approach to inspect and extract data. It in general, it's a different way that we often see in languages without pattern matching, where you usually need to like check piece by piece. And one of the nice things that pattern matching brings you actually is this idea of exhaustiveness checking. It's not completely tied to pattern matching, but with pattern matching, with something like a match, or in the case of Kotlin, something like a when, it's actually easier to know whether you have hold all the cases. And you can here see, for example, that in this expression, I don't have anything like an else branch, something which I would do if nothing of this checks. But the compiler knows that I have handled every single case, so it's fine with it. But I can go back and actually say, oh, you know what? I want to have a new operator minus. And then you may have seen that this expert has turned yellow. And if I go here, it says, well, the match is not exhaustive, and this is the case that it's missing. Well, I'm showing this in a Scala, but this is, for example, something that you will also get in Kotlin when you use when. So this is one of the reasons why we want this approach in which we actually kind of specify all the different shapes our data can have, and then specify what to do on each case. So I will actually undo this so it doesn't break in some other examples. So this is like one of the approaches to pattern matching. I think this is what most people think of when they talk about pattern matching. Again, essentially joining this idea of checking some part of the data with extracting some pieces of the data, and doing this in a kind of deeper and deeper fashion. But there are actually different approaches, and I would like to show, just because I think it's quite nice, how Erlang does it. So Erlang is quite an old language. I think it's from the 1970s, if I'm not mistaken, or maybe 1990s. I don't know. But so if I open an Erlang terminal, you can actually do things very similar to pattern matching, but it works in a slightly different way. So I can, for example, say that x is 1, and then it will show that, well, the whole result of this is 1. So I can check the value of x, and this is essentially the same. Erlang has this weird syntax where you have to put a dot at the end. So let's just don't forget about that. But I can then go and say x equals 2, and then it will tell me, oh, actually, this is not allowed. And this is because in Erlang, everything, even if it looks an assignment, it's actually what we call a unification, is trying to match the two things. So when we write x equals 2, it's checking the value of x, which, as I said, is 1, and it's try to match it with 2, and it will say, well, I cannot do this because 1 is not equal to 2. So this gives you like a pattern matching error. And you can do nice things with this. So for example, you can go and say, look, I want the same value y to be uh, like having twice in the same match, which is something you cannot do in Scala's approach. And for example, this will be okay, and now y will have the value 1. But you can also, for example, try a fail one which would fail, where I say, well, I have two values in this pair, and they should be equal, they should be set, and I want to match it with 1, 2, and it will tell us this is not possible because set should be both 1 or 2 at the same time, and this is not allowed. I just want to mention this is another approach. So Erlang people can do nice thing with this. So for example, when you write a function to check duplicates in a list, you can do it directly here because, well, you can just write x comma x and it will have the same thing. This is not allowed in most versions of pattern matching, but kind of it shows that this idea is actually quite old, and being old, it has kind of a lot of variations all across different languages. But anyway, we will stay here, I think, mostly on the realm of like this thing that Scala and Java are doing, where you cannot do things like having the same thing and checking for equality, if any, because we know that checking for equality in the JVM is something where we can spend another webinar just talking about. So let's do just a simple thing for now. Yeah, so this is essentially what pattern matching is about, and I think the question maybe a lot of people have is, well, this seems to be a quite powerful feature, right? It allows you to do a lot of inspection and matching. So yeah, the question is maybe here, should every language have it, right? Is it as important as having an if, right? Every language has an if. We wouldn't think of languages without an if or a while, uh, and that's kind of the question I think this webinar is going to be about, like how can we approach something similar to this in Kotlin. Yeah, I think I have some question there. Not sure.
No, it's mostly running the responses to my question where the folks are from.
Okay.
And
yeah. Good.
Yeah. All good. All good.
I see like something. Yeah. So maybe also a bit of but if people might be thinking, because as part of the language evolution team, we kind of, one of the things we do is definitely look at what other languages are doing and what other languages are bringing. And I often get questions like how do you decide what comes in the language? How do you decide what stays outside, for example? So I have here like kind of a very simplified idea of what we actually do in the language evolution team. So the idea is like essentially we are trying to gather a lot of feedback on the language and the ecosystem. Sometimes this feedback comes from other languages doing something interesting, like in the case of Java, they've been bringing records, they have been bringing pattern match, and they have been bringing value classes, right? So those are a lot of input for us. There is also the community feedback, like spending a lot of time trying to understand what are people problems in conference and things like this. And then there is also some people which are very nice, and they actually distill their thoughts, and then they create an issue in utrack where we can actually keep this conversation going. But regardless, at the end of the day, the point is that at some point we see, well, there is a problem, there is a need in the community, because people try to write this code, and this code is maybe harder than it should be to write, or it doesn't match, the language doesn't match the expectation of our users. So in any case, like, there is a problem there. So we always try to first approach this thinking, okay, does Kotlin handle that problem we found, or the several problems we found, well enough? And in many cases, actually, the answer is yes. The problem is that we haven't been good, maybe, in explaining all of this. So I just pass the ball to Anton, so to say, and say, like, maybe there should be a talk about this, or something like this, or to our team of technical writers, and they create additional learning material. But in some occasions, what happens that we think that Kotlin doesn't handle this problem well, and then essentially we go into what I think people consider our main job when they think about us evolving the language. We write a key on Kotlin enhancement proposal. Well, we call it key proposal, although the P is in part proposal. And then we try to refine it, and then at some point we make this public. We get, again, the input from the community, and then if everything goes well, and then we decide that this is good enough, what we do is, well, the folks in the compiler will just implement it, and then it will go back again into the tech writers and the advocacy teams talking about this new feature, right? So I would say that this part, although it's not very visible, it's actually quite important from us trying to figure out, well, do we need to bring something like this, or are our users well served by maybe a combination of this? And maybe that's one of the spoiler alert. One of the things I want to bring today is that actually Kotlin maybe doesn't need pattern matching as much as maybe Java does, because it has a bunch of other features, and we'll talk about them. Things like a smart casting, things like guards, things like properties, which actually allow you to write quite short code. So that means that maybe pattern matching is not as useful as it is, as I said, for other languages.
Let's ask the community, and let's ask the chat. What do they think about it? Does Kotlin need pattern matching badly? And I would be curious, if you think it needs pattern matching, then could you explain why, and what do you do with that?
Yeah, and also if you have changed your opinion after the yeah,
Let's see.
the
Let's see.
webinar, that would be useful. But yeah, so to show this, what I have prepared is a bunch of examples for to compare what you can do in Java and how you can approach the same thing in Kotlin. And this is not to be specific about Java. This could be done actually of any language with pattern matching. But also, one of the things I want to do here is to show that, as I said, pattern matching is doing a lot of things, right? It's matching, it's doing some deeper checks, it's actually extracting values, and in some sense, these are different problems, right? They are different problems which are solved by a single feature in the case of pattern matching, but as we will see in the case of Kotlin, actually the combination of different features will solve this problem. So let me show a bit about it. So what I have here is essentially a very small model of classes. So what we are going to have is case of animals, and this is going to be an abstract class. We can define it in Java, we can define it in Kotlin, and then we will have one particular class inheriting from it, which is dog. And what we are going to do is we are somehow check that we actually have a dog instead of an animal at some point, a dog value, because, well, dog is going to be the only one which will have the bark method. So this is the first example I want to show, and this already leads me to, I think, one of the first use cases that we find for pattern matching in Java, which is what I like to call like an instance and conversion check. So if you have been doing Java, or actually any language which haven't have this kind of support, you will end up repeating all the time this kind of thing where you check that something is a dog, right? The animal instance of a dog, and then right below you write blah blah blah, and then cast your animal to a dog, right? That's just very annoying. So one of the things that you can do with pattern matching is making this check, right? So combining these two things. This is Java's notation to say, well, if the animal is a dog, then inside of the dog variable, you will have exactly the same value as animal, but now the type of dog is going to be dog. And we can check this because now we can call dog.bark, right? If we didn't have this check, essentially we wouldn't be able to do this because, well, animal is not of type dog. So this is one of the first checks we have, and you do Kotlin, most of the time you actually don't do it you do it in a different way. You use a when expression. This would also work, by the way, with an if expression. But what you notice is that you don't give a new name, right? You have essentially the same components here, right? You have an animal and you have a type you want to check. But what Kotlin does is using this feature called smart casting, in which it will actually kind of put together all the type information it has about your value at every point of the program. So the IDE shows it nicely here by having this kind of green background, and I can actually put it here and set the smart cast to dog. So you can see that we essentially get kind of the very similar code, but Kotlin does it without the need to introduce a new name. So it's kind of solving the same problem, right? It's exactly the same problem. We have a value. We know it has now a more concrete type, and we want to use it in the more concrete type. And Java and Kotlin approach this in different ways. In Java, they say, well, let's introduce a new name. And combine it with the instance of. In Kotlin, the approach is let's make the compiler keep track of this for you, and then at every point in the program, don't only look at the type that somebody has written here, right? Don't only look at animal and animal here. Also have into consideration all the possible instance checks you can do. This is the first use case, and I mean, I could just say that we can copy Java's. We can essentially do the same as Java, but without introducing a name. But actually, if I only show this example, I will be kind of lying in some sense, because in Java there is one thing you can actually do. So imagine we have this fantasy animal. We don't care about implementation, but one thing you can do with this instance of is call fantasy animal, and then say if this is an instance, dog will be the variable holding the value, the return value of fantasy animal, and this could be any function. So in Kotlin, you cannot actually do this kind of thing with a smart casting, because, well, you essentially need any way you need to give a name to the return value of fantasy animal if you want to do this. So this is actually one of the things that made the language evolution team consider, well, there is actually something missing here in the language. So I think it was a few years ago they introduced this variation of when, where you can actually give a name to the thing you want to check on. So you can call fantasy animal and then give it the name. I'm giving here animal, for example, and then when you go inside of the branch dog, you have this name you were missing before, right? You have the animal name. So again, it's a name maybe at another level because you are giving it to the return value of fantasy animal, not to the particular casting to dog. But you can see that actually there's something with where Kotlin was missing. One of the things you could do nicely in Java in this case. So we try to figure out what is the smallest addition we can do to what the language already has in order to bring this feature to our users. Because, well, this actually is quite an important example. You can see in the wild, like a lot of people use this kind of when with val inside, which I think it's a good hint that this feature was actually that was needed for the language at that point. Uh, yeah, so I think this is use case one. So this use case is essentially doing a check and then treating the thing you are working on with the result of this check. But when I introduced pattern matching, I also mentioned this part about extracting data, and this is the second use case. So I'm going to introduce a few more types because, well, this dog actually doesn't hold any data, so I need to introduce something different. So what I'm going to have here is some something to represent points and actually have 2D points and 3D points. Maybe not the most exciting example, but I wanted to show here something where you actually have a hierarchy of types. So some types which actually uh, come from the same parent. I want to do this because then I want to show that you are kind of combining the check of whether something is a 2D point or a 3D point with the actual extraction of the values, because otherwise we are not combining the check and the extraction, we are just doing one or the other. So nowadays you can actually implement this kind of thing, potato in Java. So you introduce your interface. You need to write these permits to say which are the allowed subclasses. But essentially, if you use records, this looks very similar to data classes. We can maybe go deeper later a bit on difference in this. But the point is that if nowadays, if you use records in Java, you will kind of unlock this ability to extract things from the values of the class directly. So I have point 2D, I have point 3D. They are just essentially the same, except one, the 3D has an extra component. So then what I'm gonna have here is a function which computes the length of the point, using the typical formula, the square root of the squares of the components. I don't know. This kind of things always get to me. Like I go back to the high school. Like they've been repeated so many times. I have them on my head all the time. But you can see the thing here is that here when we have a point, we need to check what is the type of point we have, right? If it's a 2D, we have two components. With 3D, we have three components. And then we can combine this with this additional parentheses and this kind of declaration of variables. So this var x, var y declare new variables, which will hold the value, would be inside those positions, kind of in the point 2D. So if we go back to point 2D, we see that these x and y are two doubles, and they correspond to the x and y positions. So here, the x and y, I'm using the same name. We will actually go a bit later into what happens with these names, but for the time being, we just have the same names in both cases, and then we just implement it. And in the case of the point 3D, we can extract the three elements and apply the same thing, right? By the way, if we do this with ifs, the compiler cannot check the softness, this kind of thing I was mentioning. So actually Java introduced what it called switch with pattern matching. So you can actually write something like this where you write switch and then you have all the cases, and then well, you essentially have much shorter code, and also this exhaustion checking, because now the switch has like a complete view of what is the type of point, which in this case is point, and what are all the possible cases. So it can, well, 2D and 3D are the only implementation of this sealed interface. This is completely exhaustive. Uh, so the question, of course, now is, okay, how do you do this if you want to do it in Kotlin? And as people who have been maybe following this pattern matching journey know, you actually cannot write the same code in Kotlin, because in Kotlin what we are missing is this extraction as part of the same match. What you can do is do it in two steps, because Kotlin has something called destructuring, and with the structuring you can get a data class and obtain all the components inside of it. So what we can do essentially here is say, well, we first check if something is a point to D. Here you can see the green, which means a smart casting is happening. So at this point, we know that point to D is, that point is of type point to D. So then we can ask the compiler to destructure the thing. And it can only do this because it knows that it is a point to D. So it knows what the type is, and then get the values X and Y. And then, well, essentially do the same square root. And for point 3D, we can do something very similar here. So if you want to go into the same direction, what you can do in Kotlin as of now is say, well, I have a check of what my type is, and once the check is good enough to smartcast my value, then I can use the structuring as a separate step and get all the values one after the other. So uh, uh, although, to be honest, and that's actually one of the small things I think that change the balance between Java and Kotlin when you are talking about pattern matching, is that Kotlin has properties. So you can actually do something like this, and we can argue for hours, but this is, I don't think this is less readable than the previous case. We can maybe argue that this one will only get the values once instead of twice here and here. Okay, but this is just such a drop in the ocean of a big application. So uh, I think that properties is one of the things that to me make this kind of matching maybe not so important as we have in Java, because in Java they didn't have a way to do this, so they've introduced records and then you can destructure this. But in Kotlin, since day one, we have properties, so you can just directly do point.x. And if you really want short code, you just rename it, right? You call it this P, and then, well, everything is super short because it's p.x, and all of that.
And even in Java, if you didn't have destructuring, like extracting the variables, you could pretty much, do the same, because with records, you don't have to call the getters. They are pretty much like properties, not really properties, but they are accessing
Yeah,
the
we
attributes
will
by the
still have
same
the
name.
parentheses, which I think may not look as nice. And given that here it's mostly, I think, a readability issue, you can argue that this. But yeah, that's true. If you have records, maybe you could have implemented this in one without having all the matching.
There is one nice comment in the chat. I think it's worth bringing up. Like, you could use the scope function with point and then have a block and then point
Yeah,
those
I mean, actually,
attributes
if
directly.
I'm implementing this, I don't want to bring that many stuff, but I will actually kind of make an extension function, and then have a getter, and then say when this, and then this actually looks even, well, the AI assistant writes the code for me, but then this looks even, well, that's the same idea as the person was mentioning with, but actually saying, well, with is a way to bring the point into scope. But, well, if we want to do this, we can actually use an extension function and write code like this. Is another possibility that uh, Kotlin would allow us to do. Uh, Good. And as I said, that's the second thing that pattern matching brings, the way to the structure thing. Uh, but there is the third thing, I think, which is the kind of combination of matching and the structure. And I think that's when things get more interesting, and that's where actually I think the ways of how you approach this language, if you only have pattern matching, and how you can approach this in Kotlin, actually are different in significant ways. So to do this, I have this use case in which we are normalizing a point. Sorry for engineers who would say that points and vectors are different things. I'm treating this here as the same thing. So and sometimes you want to have normalize this a vector and make it like the instance one. So you do this by dividing by the length. But you have to treat a special case, because if you have the point 0, 0, you cannot read divide by 0 without getting an error. So we want to treat this case especially. So this is the thing where we want pattern matching to help us. We want to be able to write nice code such that if we detect that we are in the case of the point 0, 0, or of the point 0, 0, 0, if we're in 3 dimensions, we want to directly return 0, 0 directly. Uh, so to do this, what we have now in Java is something we can do something like this. We have guards. So essentially, we can have one of these destruction and checking, and then have an additional condition to it. So say when x is 0 and y is 0, or in the case of 3D, when the three things are 0, we have a special case, and then in this case, we will just return the point. In the future, and actually I've shown this with a Scala, you will be able to directly say case point to the 0, 0, which I think is a much shorter way to do this. I don't want to say easier, but it's definitely shorter than the previous case. And then
If
for
I
the rest, we are
remember,
just
yeah, if I remember correctly, it's only possible to use logical and, right, in this expression, and not logical or.
I'm not sure. We can check. I think you can do any expression there.
Any
Uh,
expression. Okay.
Yeah, I know they've iterated the proposal and the design. So maybe at
Mhm.
some point there was a restriction. I think nowadays it's just after the when you have any Boolean condition. That we want to check this thing, and then for the other cases we just divide by length and return all of this. Uh, so again, the question is, how does this look in Kotlin? So this is one case actually where we again felt that the language was missing something, because there are many cases where you want to do a check which is not only a check for a type, right? So in the case of if it's 0, 0 to the point, the type check is it a point to D, but then we have the extra condition, are the two things equal to 0? So we felt that the when expression should have a way to easily introduce this extra condition, because it is part of the check, right? Maybe it's a difference here with the previous example where there is a check and then an extraction of data. Here we have a case in which both things are checked, right? Both the type check and the check about the values. And this is actually one of the features that is coming out in the next version. In 2.1 is guards in when. So you can check here that something is a point to D, but also check some side conditions. So in this case, whether the X and Y are about 0, 0. And by the way, you can check here that the smart casting is helping us again, because the result of this smart casting is actually known in the side condition. So you know that if the point is 2D, you have access to both X and Y. So you can check whether they are equal to 0 here. So this is a case where as I said, we have extended the language because we felt like these side conditions are usually very interesting. So another example we found that was very interesting to us, for example, if you are having some UI application, it's often the case that you want to have a case where you bring some data from the internet, and then you have the error case, you have the loading case, but then you have a case where you have the data and a case where the data is empty. And usually people represent this using the same type, some kind of success or okay, but then you have a side condition, right? When the data is empty, maybe you want to show, in your screen something that says no data was found, or no elements. And if the data is not empty, then you want to actually create your view with all the information. So this is like another example where this small site condition, the fact that you can check this small site condition directly in the when, allows you to better clarify kind of what are all the code paths that actually exist on your program, because unfortunately we cannot have everything as a type. Sometimes things depend on the actual condition of the value. But let me use this example actually to show something you can do in Kotlin, which is not so simple to do in other languages, and this is actually checking against a constant. So I haven't stressed this, but when I have the point 2D and point 3D, I actually added this 0 element, which will represent the point 0, 0, and 0, 0, 0. So this for those who do know, this thing of defining something in the companion object is essentially like defining an static thing in the Java world, something which is part of the point 2D class and not of each instance. So what we can do in Kotlin is actually just say, well, if the point is equal to these zeros, in any of those zeros, this comma is actually an or in the language of when matching in Kotlin. If we have any zero, we just return the same thing. And otherwise, we go into the point 2D and point 3D. So this is, for example, something that we found that a lot of people actually want when they want this kind of nested pattern matching. There are, of course, more complex use cases, and I will talk about this in a bit, but a lot of use cases actually talk about I want to check that something has exactly this shape, right? Is exactly the point 0, 0. And for this, actually, Kotlin gives you a different answer that what you would do in as I said, in a language which you would introduce case point to this 0, 0. Maybe it's a bit more convoluted, but it is that you introduce this constant somewhere, and then you actually write this thing here. If I actually, you could even write it here, because this is also a constant. So we like that you introduce a separate constant, but it doesn't have to be the case. You can just write point to this 0, 0, because kind of the when will just do full equality if what you have is a constant value there.
There is a good question. Can you add an enum and use it in the when expression? Because Java allows mixing.
So I'm not sure exactly what you mean by add an enumeration. I mean, you can pattern match on, sorry, you can match here on enumerations in the same way that you can match on, so I can bring an enum class like season, and then have like spring, summer, autumn, and winter, and then say, I don't know, the next season of a season, and then again we match on this, and then again the assistant writes this for us, but you can see that we can just match on season in the same way. Actually, this is a special case of this matching against constant I was mentioning, because the spring, summer, autumn, and winter are just constants of the enumeration season. We can just directly, right? You can actually see this in the Kotlin syntax, because we don't have an is as opposed to a type check. So you can just write this. I don't know if this answers exactly the question, but in the same way that you can match on classes with is, you can match on objects, or you can match on enumeration entry. So a lot of things. You can also write just a zero, so you can match on primitive types. Like if you want, you can also match a boolean against true and false, because those are constants of type boolean. Why would you do this? It's again arguable. I think some people like the kind of flow you get. I like ifs more than, but that, just the point is that you can actually do this. Yeah. So this kind of, if there are more questions, by the way.
No, it's a
So
heated discussion, so it's
keep the
nice.
discussion. Yeah. So maybe that brings me to one of the things that we are always kind of, so of course, like, being part of the language evolution team, this is something we talk about, right? How should we allow people to inspect their data and do the control flow? But actually, one of the things I that we find it it's complicated of this pattern matching is the fact that it is what we usually say positional. So the matching depends on the position. Let me bring you an example. I found myself once, and I think it's so imagine we have this name class, right? And we, when we talk in English, it's usually the first and the last name, but other cultures don't do it in the same way. We've been discussing before this webinar how we as Spaniards have two last names to make everybody's life difficult. Uh, so we approach this and have a given name and a family name, right? Let's use just names which are a bit more generic, right? And then you go and then you try to refer politely to somebody, and then you use this destructuring, and then you have here a last, and you kind of hope that this last refers to the last name, because maybe somebody where on a culture where the last name goes before will just write this, just have the family name before. And there are no ways to differentiate these two things, because the name you write here is actually completely unattached, is detached from the actual thing you are doing. This doesn't tell you that this is the given name or the first name. You are on the darkness in giving a name here. So you can see that most people will actually resort to doing things like, oh, I use X1, Y1, Z1, so something which looks very similar to the name you had, or something like this. But I mean, there is nothing stopping you to calling them blue and red if you are matching on a point 2D. That's allowed. And in the cases in which the types are not enough to disambiguate where you want, right? You can actually mix them very easily. And when thinking about this, I mean, one of the feelings was there is that this has a lot to do with the fact that this matching is positional, right? That the fact that you are not bringing the names of the things when you are matching on them. And I mean, we don't know the answer about what should be, but kind of our exploration here is also a bit on, if we want to bring something like this where you can destructure things and match on things, maybe it has to be done in such a way in which the names matter, in which you maybe are more explicit about the actual thing you are matching. Maybe you are, you need to follow some rules, and so that's kind of where we are at now. If people are like curious about all this thing, how is it may evolve. Uh, but again, going back, I mean, the thing is that again we have the point dot x, which is like again very explicit, right? I'm actually accessing the x thing on point, and that's again like a thing to say. Well, maybe the property syntax, even though it's long, it's maybe long. Sometimes it has the thing that you are always very explicit about the field name you want. So that's one of the things where we feel like the usual pattern matching maybe falls a bit short into having this disconnection, and we are exploring ways to make this connection more explicit. Again, I don't know what will be the future, but that's one of the things also blocking us to how to move and just bring like a copy of general pattern matching to Kotlin, because we feel like this is a problem that people fall into when they use pattern matching. They just use the same, they just have to bring a new name for something which already has a name, right? It has a property name. They have to invent a new name, and there is no, again, connection. So now you add a new field, maybe the order of the fields change, and suddenly your code may continue compiling, but now it's wrong. So positional is good if you have tuples, if you have lists, but maybe for the rest, something more name based is a better choice.
What if we had both? I mean, there was a comment like it would be nice to have both. What if we had both in Kotlin, the name based and position based?
Yeah. Again, I don't know the answer right now because I mean, I guess that the structuring, which is now positional, so this thing I do here cannot go away, right? We cannot suddenly change positional to name based. So I guess at some point there would be some combination of both, and maybe that's a good thing. Like, right, the community will decide which is the best approach, or maybe they will decide if I'm using tuples, I use this. Otherwise, I'm using this. I don't really know the answer there, but definitely that's a possibility. Uh,
Okay.
yeah. So maybe
There is an
yeah.
it's an interesting comment. Probably it actually is related to the next part of the content you're going to present, but there's like I cannot just skip it. Would it be possible to create a gardener property? This is an interesting feature. I haven't even thought about this one.
Yeah, so I mean that essentially I think would be, it's a different question, which is whether you would be allowed to I think have this nested pattern match. Is again something that Kotlin doesn't allow to do now. So if if Kotlin had nested pattern matching, I guess that's kind of what you would get at, right? You would have is point to D and then say, oh, now I go into the variable property X and then I check a new type of this. This is also where things get hairy with the syntax, right? How do you bring a name which is a val, and then you
Mhm.
also do the check? So that's things get bigger and bigger. But I mean, could you do this? You could do this because the language is not fixed in that case. Uh, and I guess it, again, if you bring the whole pattern matching to Kotlin, that's how it would look like. The question is whether this is something that you really need.
Okay. All right, let's move on. I think we have some
Yeah.
interesting
So
stuff in front of us. Yeah.
yeah. So something that I also wanted to mention, because right now I think the it looks like, well, okay, you are comparing and you are just showing things that you can do in Java and how you do it in Kotlin, but it doesn't mean that Kotlin is just doing poor man's pattern matching, which all this Smartcast and all of that. So I wanted to bring a few things that actually Smartcasting allows us to do, which is very difficult to do in a language which has only pattern matching. So I have these things here. So one thing that first is allows to do is that uh, kind of pattern matching is kind of a very syntactic thing in nature, in the sense that you have there exactly the check, right? You have the case point to D, and then you know that the thing is a point to D. But in many cases, the flow is a bit more complicated, right? So this is a very small example, but this happens a lot, that you are checking if something, for example, is a dog, or what we do inside the compiler. If something is, for example, a function type, and then you do something else based on this Boolean, and then at some point, what you would like is, if you have already checked that this is a function type, if you are doing pattern matching, this forces you to do another check, because the pattern matching is the only way you can change the type. But with the smart casting, this is actually a bit more free. So I can have actually a Boolean saying, is my animal a dog? I work as if it was an animal at this point, because I don't know, right? At this point, I haven't done anything. I don't know anything about the animal. But at some point, I actually say, look, go into this branch only if this is dog is true. And the compiler and the smart casting framework is clever enough to say, well, actually, this is dog brings some information about the type of animal. So then I can call bark again, which is, remember, that was the way we were going to notice that our animal was actually changed to the type dog, and also the green background in the. So this is one thing, the more free separation of checking the type of things. And by the way, I'm showing here is dog, but this could actually have an additional, I don't know, and 2 is greater than 3, something like this. This will actually be false, I'm sure, yes. But you can have additional things, and the compiler will only use the ones which are actually important for the smart casting. So this just me trying to say that this doesn't have to be exactly blah is dog. The compiler is actually clever and knows how to treat ands and or and nots and things like this. So this is one of the nice things that the smart casting brings. The second thing is that the smart casting also interact with the contract in Kotlin. So we can have a special Boolean condition where something is a dog, and the name, the breed of the dog includes husky, like and then we have a contract here which we say, well, we are going to check if the animal is a husky, but even more, we are going to state in a contract that if this function returns true, we know something about the animal. We know something that actually is a dog. So this information, which is about what happens when you execute this function, can actually be brought when we use this as a match. Sorry, as a match in a when. So we do here when the animal is husky, and then we know because of the contract that that means that the animal was actually a dog. So we can call bark on it. So we can again, what we see here is a bit more of kind of decoupling of the checks of things and how they actually affect the values they talked about. And this is something that we can do because, say, a smart casting doesn't work by syntactically saying, oh, you have a case here to this. Actually works by kind of adding and aggregating information about the flow of the program and all the potential information about the types it has. So it can be from many different sources, not only from the match itself, but actually from contracts, from conditions and things like this.
I have to say, I just learned something new today. I was curious about some of the standard library functions that I didn't check how they are implemented. Now I know they are implemented using the contracts, and the smart casting is coming from there. Nice.
Yeah. So really nice when you can actually state that this means that something is not null, because that's also kind of part. I haven't mentioned it, but also part of the things which go into the smart casting. So all the nullability is kind of built in together with the types.
Cool.
So if we have time, I mean, to be a good researcher and actually show like when these things fall short, because there is a case when it falls short, I feel, and for full disclosure, like there is one thing where actually you really need, well, they're not a case, but there are like a few occasions where you really need this kind of complex interaction between matching and extraction. One case I often see is simplifying an expression where you want to say like if you have 0 plus n, this is the same thing as simplifying n and things like this. And in that case, you really want to do very deep checks where you have a binary of a number literal and then a constant, and then and this is something that indeed becomes harder in a language with a smart casting instead of pattern matching. Another question, and that's the up for discussion, is how often do Kotlin users write this kind of code? And our preliminary kind of investigation is that people don't do that often. Like they most of the time do like at most twice. Like they check that something is of a type, and then they check a value inside of it, and they don't go that far. And that's how we also came to the conclusion that something like guards could actually work, because a guard essentially gives you a very simple way to have a first level of checks and then do a second side checks maybe on a deeper level, and it gets harder as deeper as you go. So I said this was kind of the looking at how people use Kotlin in the wild, the kind of checks that people are doing. So it's kind of uh, trying to work with the kinds of things and kind of leave out a few percentage of more complex matchings. Uh, and this kind of give us the trade-off of not having to bring a full thing like pattern matching, which is actually quite a complex feature, right? You have a lot of interactions. I haven't talked about, but how these names come to be. What if this name is equal to another name? All of these are interaction we need to consider in the language, which makes pattern matching a quite complex feature. So that's kind of the balance here, right? Do you want to bring the whole pattern matching to maybe cater for this few percentage, or then you feel like this maybe goes away, and then you want to bring some of the things we've mentioned, the guards, the when with val, but have a smaller language.
Nice. Um, so, are we going to dive a little bit into the guards as well? I guess we had example for that, and
Yeah, we can talk about guards a bit if you want. I have them
I'm
here. Here, yeah. So yeah, maybe I was a bit fast here. So guards is this new feature that comes in 2.1 and allows you to do a side check in addition to kind of a main check in a when. And this is this part here I have with if. Uh, so how we should read this is that this we only go to this branch, we only execute the body if everything here is true. So if both the point is a point to D, and also this thing is true, so you can kind of think like of this of an and between the two things, uh, and kind of the integration. Since we are talking with a smart casting, what happens is that everything we know from this first check is actually available in the second check. People who are using Kotlin uh, may notice that, for example, this happens a lot in Kotlin. If you check that something is not null, and then you do and, then the fact that the thing is not null is already taken into account in after the and, so you don't have to use the question mark dot. You can use the dot and things like that. Uh, but yes, and if these things doesn't match, then well, you just try the next one. So it's like
right.
having so in that sense it's different from like nesting, right? So if you want to do this with nesting, you actually need to handle the cases a bit differently, right? Because once you go into the is point to D, then you cannot go out of that thing. This side condition allows you to don't go to point to D if this is not true. So it works a bit differently. That's why we need something like guards, because this is not exactly like nesting stuff, just in a smaller fashion. It allows you to create a bit more complex control flows. Uh, yeah, but for the rest, how again, as how it should be read is that you just go into this branch if everything uh, that you have in both the main condition and the rest of the condition is true, and otherwise you keep trying for the rest. Maybe something interesting is how it affects exhaustiveness. So because these things are in general any kind of condition, and we don't know what the condition are. They could be any call to a function, or check whether something undecidable is true. Who knows? What we do for exhaustiveness is just don't take that into account. So this thing is exhaustive because of these two branches, because the point 2D and the point 3D. These things are not taken into account. They don't work, and we actually checked that this was uh, uh, kind of it gives you like a recipe to do things. So you really want to use guards when you have side conditions like this one. If you have something, for example, as we had before, where you want to treat a binary operation and then you want to check every possible operation, if you want exhaustiveness, what you have to do is check the binary and then in a nested check all the operations. If you do this in a guard, like having, if this is a binary operation and the binary operation dot operation is plus, minus, and all of that, this won't give you exhaustiveness. But that's kind of, I think it gives you a recipe when it's nice to use guards. Again, when it's like a small side check for a very special case, as opposed to maybe how this is approached if you have a more general pattern matching, where actually people in a Scala, as I said, will happily write this plus times and an or, even though they are essentially repeating the same match here for the binary case, because this gives like a more readable thing in your language, which we cannot get in Kotlin. So as I said,
Mhm.
essentially, it's a guard if it's a side condition. Otherwise, if you want exhaustiveness check, you often need to go into nested matching.
One thing that I started to think about is how you order those checks within the when block. So if you currently would bring the match for the 2D point in front of the expression with the guard, basically the second one is unreachable. But
Yeah,
this
you will see
this
it. I
this one,
actually get some here. Like it's never reachable because these are tried in order. So
this one is pretty obvious, but what if we had the type match for 2D point with a guard expression where we once check if x is 0, and then the other one where we had a check with y if y is 0. You see what I mean?
yeah, yeah. Oh, an ID error occurred. This is why. I mean, this is why we need to do some EAPs before releasing things. I don't know what's happening actually now. Uh,
Hmm.
Equals 0.0. Okay,
Yeah, the ID
I
is
will tell.
not ready for this feature yet,
But
it seems.
anyway, so the answer to your question is yes. In this case, you will actually you will never reach here, right? Because this other thing is true already. And in some occasions, IntelliJ is clever enough. I think in this case, that's what I want to show. I think it's clever enough to tell you, well, when you get to this point, this is because these two things are true. So this is kind of unreachable. But in general, that's something which may happen. That uh, a previous uh, guard actually takes all the values of something afterwards, and then the other one is never checked. And in that case, yes, it's true that we cannot really give you a warning because we do not inspect the body of the functions when doing this, right? We only know about simple things like if you have something and then afterward you have the same thing and another thing, that's very clear and it's very local. But that's something you can't. So that's
Hmm.
maybe something where you need to uh, take a bit of care. My usual recipe in any ways is always to like have the special cases and then the general cases below. Some people like to match them, like to put them in between, like all the point 2D, like the first special cases and then the general case. I like this case again. That's more like a personal taste for all of this. But yeah,
Hmm.
once you introduce guard, you're essentially in here. You're essentially in Boolean expression land, where we cannot check so easily whether things are yeah, you said overlapping or not.
Right, right. So a minor thing about the syntax, right? So when we published or announced that there will be this if expression, I think some of the folks were either confused or disappointed why we didn't do the same syntax for Java because they have when instead of, or was it when?
Yeah, in Java they use when.
No, no, they have with.
No, they I have the example here. it's when right now. They
Ah,
also
okay.
change
Yeah.
between iterations.
Okay.
Yeah.
Yeah.
So long story short, well, it's actually two stories in one. So one thing is that yeah, that whether it's if or when, uh, it's mostly the fact that they can use when in Java is because when doesn't have the same. When is already a keyword in Kotlin with a specific a specific uh, thing with a specific meaning, and it wasn't so easy to like make the whole thing and parsing and all of that understand what it was, as compared to if. Like another possibility would have been where, which also has like a very like a smaller uh, uh, thing. You like where in Kotlin is very narrowly used only after some type, and sorry, after some signature and so on. So that could have been another possibility. In that case,
Mm-hmm.
we thought that if was a better choice. Another reason why you can do this is because, well, I haven't showed it, but you can write an else, which like what if you don't want to have a check over point, but you want to do some side condition. The syntax right now is uh, looks like this: else if, which is like a nice way it reads, right? Like you have else if in the same way that you have else if with the other thing that was like a pro with if. The other thing that we consider a lot on the whole story is that if I want to like inline the point, I can do it this way. Uh, but then I have to write and here.
Mm-hmm.
Uh,
Mm-hmm.
and then I need to remove the else if. Uh,
And
so we
then
consider and.
yeah,
Uh,
and then you don't really do the exhaustiveness as well. Like if it's
yeah, I mean, if
important
you write this, you
to
don't exhaust it, but I mean, like, what I mean is that we thought about writing something like this, where you
mm-hmm.
have and here, and then maybe else if, I don't know, for the else. We didn't know the answer there, but the problem with that is that it doesn't have a very good interpretation with with when if you have an or here,
Oh
because
yeah.
what you would expect is that this or means this thing or this thing. That's how priority usually works with and, right? That the or has
Yeah.
a priority. But this was not the case. When you were using a guard, you would have to read it this way. And we could teach people how to read this. We could have like a special compiler warning saying, look, if you have an or, please write parentheses because you might be doing the wrong thing. uh, but at the end of the day, we kind of decided that if was good enough and we went with it. This doesn't mean like I drove this key proposal. I don't feel strongly about all of this. I see pros and cons. I think if fits the bill, I think it gives a clear information that you are some condition, right? Because if it's very attached to the notion of conditional, so I think, and I like that you can write else if uh, as a minor point. Uh, but yeah,
Mm-hmm.
for those of you who know, like when we go to 2.1, the feature is actually in beta, which means that we make a promise that we want to have this in the language, but maybe the design may change slightly. Well, I mean, if everybody thinks that another syntax is nicer, this could be changed. I,
Mm-hmm.
I, yeah,
I see.
but it's also like a sometimes very personal, right? You like when, you like if. They are all kind of the same kind of keyword, right? They are conditional, like they already exist in the language. When we don't have to add keywords to the language, which is always backwards compatibility. So both could fit the bill. And again, we chose if this could be reverted to when, where, or something else.
Perfect. So yeah, it's over the long period of time. I can see for the first time this kind of heated discussion in the chat. It's so nice to see people discussing it and sharing the ideas. Thank you, Alexandro, for for this awesome talk, for this awesome story. And folks in the chat, tell us, how do you like the format? We plan to bring more members from the design team to talk, or language evolution team, which was the correct name. Bring more of them to the live streams, explaining how one or the other feature was designed. Hear your feedback, like we are listening. And thanks for coming, everybody, and have a nice Kotlin.